Hello everyone. In today's lesson we're going to look at scientific notation, which is a way for us to represent very large or very small numbers more conveniently, more easily, and in such a way that we can input them simply into a calculator. So in science, a lot of times we run into either very, very large numbers or very, very small numbers. Like for instance, let's say we're doing a calculation where we're working with the mass of the sun. So the mass of the sun is a very, very large number. Here it is in kilograms. This is something that is very difficult to write out, first of all. We wouldn't want to have to write out all those zeros every time we have to add or subtract or multiply or divide with this mass of the sun. It's also something that we would have a lot of difficulty putting into a calculator. So one way that we can deal with this type of number, this type of large number like the mass of the sun more easily, is to convert it into what's known as scientific notation. So let's put this mass of the sun away for a little bit. We'll come back to it a little later on. And let's talk about scientific notation. So if we have a number like 1,000, and let's make it a measurement. Let's say this is 1,000 grams. The decimal place in this number is after the final zero. So after that final zero in 1,000, there's a decimal point. Now, 1,000 is the same thing as 100 multiplied by 10. That gets us 1,000. Similarly, 10 times 100 gets us 1,000. And as we all know, 1 times 1,000 equals 1,000. So what's the point of this? Well, 1,000 can be written a number of different ways, as we see here, as a product of one number and another. So if I want to change 1,000 into what we call scientific notation, what I'm effectively doing is moving this decimal place. And I'm moving it to the left. Each time I move the decimal place to the left, the number must be multiplied by 10 in order to get the original number. So if I move the decimal place 1 to the left, I have to multiply 100 by 10 to get 1,000. If I move the decimal place 2 positions to the left, I now have 10 multiplied by 10 times 10, 10 to the second power, to get 1,000. And if I multiply the decimal, or rather move the decimal, that is 3 places to the left, I now have to multiply by 10 times 10 times 10, or 1,000, to get 1,000. 1 times 1,000 is 1,000. Instead of writing out times 10 times 10 times 10 in this last example, it's a lot more convenient for me just to say 1 times 10 cubed, or 1 times 10 raised to the third power. And get my unit back here, 1 times 10 to the third grams. This is another way of writing 1,000 grams. It's written here in scientific notation. So we're just moving the decimal so that we end up with a number between 1 and 10, and then we're multiplying that number between 1 and 10 by a power of 10 in order to obtain the original number, so that this scientific notation that we see here is representative of the original number. And we can do the same thing with small numbers here as well. So let's take a look at another number. Let's say we have 0.001 centimeters. Now in this case, the decimal is over here to the left of the first leading zero. And I would need to move the decimal then to the right in order to change my number. So if I do the decimal, move the decimal to the right here once, I get 0.01. And the effect of moving the decimal to the right is the same thing as multiplying by 0.1. So we see that 0.01 times 0.1 is 0.001. And 0.1 is the same thing as 10 to the negative first power. So what I actually have here is 0.01 times 10 to the negative first power. If I keep moving the decimal to 3 places, I now have 1 times 0.001, which is equal to 0.001, or 1 times 10 to the negative third power, because 0.001 is 10 to the negative third power. And I'll put my unit there, centimeters. There we have 0.001 centimeters written in scientific notation, 1 times 10 to the negative third centimeters. So what we see here is that to express a number in scientific notation, let's say we have a number 4,750 kilograms. All we have to do is move the decimal until we obtain a number between 1 and 10. So I'm going to move the decimal one place. I get 475. That's not between 1 and 10. So I move the decimal a second place. I now have 47.5. Still not between 1 and 10. I move the decimal one more time. I get 4.75. That's a number between 1 and 10. So that's the first step. Move your decimal until you get a number between 1 and 10. The second step here would then to represent the number of times you've moved the decimal place with a power of 10. So I've moved my decimal place to the left 1, 2, 3 times. So I'm going to multiply 4.75 times 10 to the third power, and it's still kilograms, and there is my number in scientific notation, 4.75 times 10 to the third. It is important to point out that proper scientific notation must include a number between 1 and 10. We call this a coefficient. And then a power of 10 here, which we call an exponent. And that coefficient must be between 1 and 10. So in other words, must be greater than 1 and actually greater than or equal to 1 would do it, and must be less than 10. Not less than or equal to 10, must be less than 10. And those are the rules for expressing a number in scientific notation. So if we go back to the mass of the sun then, remember we had this big number for the mass of the sun, difficult to write, difficult to work with, difficult to put into a calculator, if not impossible. This number can be expressed then in scientific notation by moving the decimal place until we end up with a number between 1 and 10, and that number is 1.989. Now, how many times do we have to move the decimal place to get there? Well, it turns out it is 30. So this is 1.989 times 10 to the 30th kilograms. And that's how we express the mass of the sun in scientific notation.